Welcome back, friends. We are continuing our discussion on plant nutrition. In the previous session, we discussed about the tax movement, and as I told you that we discussed the advantages of tax key movement. As we discussed in the previous session, as a part of recap, we said that the tax key movement or taxes, they are plant movement involving the wool part of a cell, I mean the wool cell or a wool organism. And we gave some example for tactic movement which are performed by a plant. Tukatoa examples za euglena, tukatoa examples za sperm cells, liverwort pamoja na Moses plant, tukatoa examples za chloroplast. However, we said chloroplast is an organelle, is not a cell in such. Lakini hizo ndo ziko examples. Now let's go to discuss about the importance of tactic movement. First, it drives an organism towards the requirement for physiological needs. It drives an organism towards the requirement for physiological needs. For example, euglena moves tactically towards the source of light for photosynthesis. So that means the physiological need for euglena is light for photosynthesis. Kwa hiyo euglena move by tactic movement and move towards light, and that help euglena to move towards light. That is the physiological need, and help the euglena to produce its own food by photosynthesis. The second point, that to drive an organism away from the environment that are not conducive for its survival, hence increase the survival chance. Example, mosquito escape from repellent in negative chemotaxis. As we gave an example in our discussion in the previous session, that the mosquito, they run from mosquito repellent, and that the example of the negative chemotaxis. Kwa hiyo that is an advantage because it drives mosquito away from the environment which could be killed or which could be harmed. And the third advantage is that reproductive significance, to bring organism into closer proximity or reproductive purpose. Example, male insect tend to move towards female under influence of courtship pheromone secreted by the female. Pheromone is a kind of chemical which is secreted by some insects. So it is a kind of chemical which tend to attract a male insect for reproduction. And not only for insects, but also, even I told you about the pollen grains in the previous session. Kwamba in a pollen grain, tuna a pollen grain which is positively chemotaxis, positively. Actually, a pollen grain is like not a whole cell, but it is a cell, because a pollen grain is the reproductive cell. So it moves towards the ovule. That is one among the example, because it gains reproductive advantage. In absence of the chemicals produced by ovule, it could be impossible for it to move towards ovule. So chemotaxis help organisms to come into closer proximity and to do reproduction for generation to continue. And let's move into nastic movements. And as I told you before, that it is very important to know the differences between taxis, then tropism, and nastic. In nastic movement, we define it as the non-directional movement of fixed part of stationary plant in response to external stimuli. Now you see, the difference between tropism and nastic is that tropism, it is directional. It is directed by the stimulus. The direction is either towards or away from stimulus. That's why in tropism, we can classify it as positive or negative phototropic. But in nastic movement, it is non-directional. So nastic movement, they are non-directional. Yani, hauwezi you can determine direction, either it is positive or negative. But it is a movement of a plant in response to the external stimuli. So nastic movement differ from tropic movement in that direction of tropic response depends on the direction of stimulus, where the direction of nastic movement is independent of the stimulus position. Also, tropic movement is a growth movement, while nastic movement may not be growth movement. So nastic movement na tropic movement kulizwa differences they are two. Firstly, tropic movement is always growth movement, while nastic movement it is not normally growth. Sometimes it is not growth movement. And the second point to stand with is that nastic movement they are independent on the direction of the stimuli, while tropic movement they depend on the direction of the stimuli. Now we have different categories of nastic movement depending on stimulus. The first stimulus is the diurnal variation in light and temperature. Diurnal variation in light and temperature they lead to movement of different parts of the plant. Na ndio maana ukija asubuhi utakuta mimea majani yamekaa vizuri, ukija mchana utakuta yamenyauka, jioni tena yanakaa vizuri. That's the nastic movement. Now direction ya jani kunyauka huwa haijulikani. It is where in mlatu ukipata joto umefanya transpiration inanyauka. Kwa haijulikani kwamba itanyauka kwenda kushoto kwenda kulia. It is not direction, you cannot predict it. So that's why we call it the non-direction. So we have the nastic nursery. Example is leaflet of leguminous plant fold in evening and open up in the morning. Some of the leaves of leguminous plant they fold in the evening and then they open in the morning. That is, and the direction of folding and opening, it is a non-direction. There is no specific direction. That's why we call it as a nastic movement. And then we have touch or shock. Kitu kipata shock or touch, and especially here we are talking of plant. Hapo tunakuwa tuna seismonastery, some kind of like vibration. Hapo example is leaves of Mimosa pudica show this kind of movement. Huyo Mimosa pudica plant kimgusa tu leaves zake they are doing like as if they are closing. And the direction of closing, there is no specific direction. You can't state the specific direction of closing of leaves. So that's why we can say that there is no specific direction of closing of leaves. That's why hatuwezi kusema kwamba kuna labda hizi leaves zina close kwenda kulia kushoto. No. And then you have temperature, that is thermonometry. For example, is opening and closing of flowers of tulip. Huyo ni mmea, kuna mmea unaitwa tulip, and the opening and closing of that flower of tulip, of the flowers of tulip plant depends on temperature. Kwa hiyo that is thermonometry. And then you have light, which is photonometry. In photonometry, example is the leaves of oxalis take up horizontal position in sunlight and it drops down during night. So you see, kwamba horizontal position, actually you can say just only horizontal, but we can't state a specific direction. Kwa hiyo inawezekana tegemea na direction ya plant, hiyo plant yamekaje, lakini hivyo ndivyo ambavyo tunaweza kusema kwenye photonometry, they take up the horizontal position and then during night they fall, but the direction of falling it can't be stated kwamba ita fall kwenda wapi. And then we have contact. In contact we have thigmotropism. Contact or touch we have thigmotropism. And in thigmotropism, example is in the leaves of certain insectivorous plants such as Drosera. So insectivorous plant they tend to sense for the insect ambayo ataanguka pale kwenye jani. Insect yakianguka pale kwenye jani, the insectivorous plant they tend to fold their leaves. So the tentacles show variation in movement on coming in contact with an insect. So presence of insect on the tentacles of the Drosera tend to alter its shape or tend to alter its movement, and that movement cannot be stated. The direction of folding of the leaf cannot be stated. We have some kind of the importances of nastic movement. The first importance is that the movement is the survival value. For example, the leaves of flower can be favor of avoiding unfavorable condition. Leaves of flowers, folding of leaves, or even shrinkage, wilting. Wilting ni just kunyauka tu, lakini then conditions zikiwa nzuri zina recover tena. Kwa mfano, it is very important, for example, in transplantation. In transplantation, the wilting of some kind of folding of leaves allow the closing of stomata, and that closing of stomata, they enable the leaf to not lose, or enable the leaf to reduce the amount of water lost. Kwa hiyo that's very important kwa sababu tukireduce the amount of water lost means tutakuwa tuna high amount of water in the plant, and thus tutafanya mmea uweze kuishi or survive many days. Another example of nastic movement is that nastic movement are for food opportunity. For example, carnivorous plant tend to close their insect trapping pouches upon being stimulated by the trapped insect. So nastic movement, they are very important even in the carnivorous plants. Kama tulivyotoa examples, ni one among the types of nastic movement it is touched in the monastery. So in this session, I am ending up here, and in the next session, I will start our discussion about the plant growth substances, or sometimes they are called as phytohormones, plant growth substances or phytohormones. We have the major 5 groups of phytohormones, but before discussing the major 5 groups, we will first discuss about the characteristics of phytohormones, and then we will go into the details of one phytohormone after another. And after finishing the phytohormones, discussing the discovering the synthesis and the distribution, discussing about the function in the plant, and then the commercial application, it will be almost the end of our topic of coordination in plant and the coordination as well. So thank you everybody. Don't forget to visit my blog. There are notes there. You can go there and you can read the notes. And don't forget also to follow my blog, so when I will be posting every kind of post, it will be easier for you to be notified by email, and then you will visit the post, and then it will be very important for your reading purposes. And don't forget to click the link below to join my Telegram group for discussion and for any concern. Thank you everybody. Later I wish you nice studies. Thank you.